Hello, good morning, everyone, or good afternoon. It depends where you are. I'm so happy to be here today. This is the very first session of Tech Community Day, a really great way to kick off the day with a workshop from Markus, who is directly from Austria. So say hello, Markus. People can see you
Hi,
now.
everybody. Hola.
Thank you. So, Marcus, session title is Search Service AI with Power BI. I will have a few introductory slides just before I turn over to him. This is free event. It's organized by the IT community. Some of the most important IT communities from Guatemala: the SQL Server User Group, the Microsoft Dev Group, the Docker Guatemala, and Kubernetes Guatemala communities. Here's our social networks. If you want to connect today, I really recommend you to follow us on Twitter, like the fan page on Facebook. Also follow or subscribe to a YouTube channel so you don't miss any of these great sessions. If you need technical assistance, you can just throw your question into the chat window in YouTube, or you can join the Slack channel and post your questions there. Marcus will be hanging out with us later this session, right, Marcus? A little bit
Yes,
just to address any questions. So feel
definitely.
free to drop any questions during the session. I will be collecting those questions for Marcus, and we will let him know that you have something to share with him. All right, so I think it's time to turn over to Marcos. By the way, my name is Carlos. I'm
Hi,
today's
Carlos.
moderator. Hey, Marcos, thank you. So I'm turning over to him right now. Let's see. There you go.
Yeah, that's right. Yeah, welcome to everybody. Unfortunately, I don't speak any Spanish. Is it Spanish in Guatemala? So no español,
Okay.
except for maybe una cerveza, por favor. But yeah, very broken Spanish. Yeah, welcome to my talk about self-service AI with Power BI Desktop. Let's start with that. It's about AI, and to be honest, I did not use any academic definition of AI. I just thought about what is interesting things, what are interesting features, which are just fascinate me in Power BI because they help me so much that I think this is really intelligent. So you will see stuff from doing in the GUI, in the graphical user interface, and we will also see some scripts. So depending on your level in Power BI, on your level in machine learning and those scripts, I hope for everybody there will be something. I will start easy with the graphical user interface, and then we will turn over to more scripts. And the goal from my perspective is to show you what kind of features are available, to inspire you what you can do with data available in Power BI. From the features, when I started this talk, maybe a good year ago, I started collecting stuff for this kind of talk with this title. There were a bunch of features, and I soon found out it's just not doable to show everything. So I just deleted all the slides. Did not delete them, but I moved them to after the demo, and I will demo as much as I can. But now the features are even more. So for example, in reporting, you can use question and answers. We have the insights feature, the analytic line, key influencer, and decomposition tree visual. The later one just got a general available in the June edition of Power BI. We have smart custom visuals we can load into the Power BI file. There's this what if parameter feature. Then we have scripts, which we can run for, of course, in DAX, but we can also integrate R and Python scripts. I'll show you some of those. And there's Power Query with cognitive services, which we connect to, or we can connect to Azure Machine Learning Services. We have also these nice features, column by example and web by example, which I think are smart features and close to what artificial intelligence can offer to us. So for today's session, I just chose a bunch of those tools. So we will concentrate on some analytics we will do with the correlation and time series analytics. That's what I decided on to do today to make this talk a little bit different every time I do it. So now we're going to demo, and we will not leave the demo until the very end of this session. There will be one slide per feature I showed you with a reference to the documentation, so you can look it up there if you're interested to see more there. Where is my demo file? Here we go. What I've prepared for this talk is an AdventureWorks DW. So I have AdventureWorks DW connected or loaded into this Power BI file. I will share this Power BI file. I will share the slides afterwards in the Slack channel, and I will tweet a link to it so you can download this afterwards and play around if you want. The first feature, which is really, really nice, when I first saw it, I thought, yeah, that's nice for demos, but who will really use it, is the Q&A feature. So there's several possibilities. One, the easiest one I really prefer is to just double-click on the report pane, and then the Q&A is opening. Do I got double-click? Come on, yeah. Here's the Q&A feature, and then we get this bubble, like in a Bing or Google search, or if you're old enough, Yahoo, for example. Now we can type. So there's suggested questions like top size ranges by total product cost. So Q&A is analyzing my model and know that there is a column top size ranges and there's total product cost, and it could show me that. Or I can just type a question. For example, sales amount. I'm asking for sales amount. And if it understands the thing, then I get this blue line underneath. So it knows what sales amount is. And this is a really bad model because I have different versions of sales amount. As you can see, there's sales amount, there's sale amount, there's a new and new diff, and so on. So this is bad habit. This is only for demo purpose. In your real world model, you would only have one measure with sales amount, of course. And if you take a look, then we see this 80 millions. If you're aware, working with AdventureWorks, you know the reseller sales, the sales amount, the sum of the sales amount in the reseller sales table is 80 million. So I got this KPI measure here showing me that this single number. But we can continue typing. So I can ask for by category. Then it will show me the numbers divided by, or one bar per product category. This discovered category is another column in my model, and it knows category is categorical data, so it makes sense to put this on a bar chart. And I really like this because the default is just, useful. We can use this and build our first report with that, our dashboard report. We can also different stuff. So for example, I can ask again for sales amount by promotion, and we type in here promotion for 2013, for example. So we can add a filter here. So Q&A is smart enough to discover 2013. This is not a name of a column. This is the content of a column, of the date column. Again, we see that there's a date and there's a DS column because it's just a model for demo purposes, not a real world model where I would only have one date column, of course. And if I press OK, then we see the numbers, like the different promotions. No discount is really huge, so I can't see the promotion. But what we can do is that we can convert this, pressing one single button, I can convert this to an ordinary standard visualization. So this is now a standard bar chart. And of course, because it's standard bar chart, we can change things here. We can, for example, see that there's a filter was added. Here is 2013. This was done by Q&A. And we can, for example, we can also change and exclude the no discount. So this is easy to do because this is a real chart. And I discovered more and more that I use the Q&A feature very often because it's the fastest way to get to my columns instead of looking them up in the fields pane where I scroll up and down or use the search field. I just can type it in directly here, which makes me faster. There's also an example, sales amount by, is it, which territory? I always have to think about it. I think it's territory region. Is it? I think the group is. Let's have a look if it is working out. Yes. So for the territory group in my model, I defined this. This is an geographical information, and therefore Q&A comes automatically with a map. To be honest, I don't like the map very much because the people I build reports for, they know where North America is or where Europe is. The Pacific, we can discuss if this is really good to put the Pacific in here because indeed it's the Pacific region which will be, for example, Australia and New Zealand. So the dot is like not really there where I would put it. And there's one region where we cannot define a group, so NA for not available, and this is put to Nairobi on the south tip of Africa. So there's plenty of reasons why I don't like maps, or single maps, or simple maps like that one. But you can change this again. That's why I'm showing this feature with the map as bar chart. So we can also ask, we can communicate with Q&A and ask for doing stuff for us. So this is also possible. And if we use the sales amount by date, for example. Again, if you discover date is a continuous data, and then we put it on a line chart. Easy as that. So this is really cool. Double click on the pane, just start typing, and I think this is the fastest way to make up your visualizations. If there are any questions about Q&A, this would be the right time. Carlos, are there anything in the chat? Then let me know. Otherwise, I will continue here. Sales amount by date. And do more analytics with the date here. Convert this to a chart, and then we see the date, the sales amount over date is really volatile. So it's going up and it's going down and up and down and up and down. But my gut feeling tells me over the sake of those 3 years, we have an upward trend. So the numbers there are on average higher than here. I mean, this is not really true because it's really volatile, but this is my gut feeling. The thing is, can we prove this? Because doing decisions on purely gut feeling is probably not the best idea. And we can, for example, we will add this afterwards. What I want to show you first is this feature that we have like this peak up there. So in January 2013, we have a sales amount of 4.2 million, which is the highest point in the whole chart. And the question is, what happened between December and January to make this big growth? Because it's also a real big jump. So from 2.6 to 4.2, this is a big jump. Can the tool help me in seeing what was happening here? And it can, of course. So we can right click on this data point and then analyze, explain the increase. Maybe I zoom in here. Can I do this? Zoom in, zoom it. I didn't start zoom it. So come on, zoom it. And then I make this easier for you. Because in the webinar, we never know how good the screen resolution will be. So again, here I right click here, and then I can say, ask for analyze, explain the increase. That's what I select, the only selection we have. And then Power BI is doing an ad hoc analysis. So ranking results, we see this light bulb here. So now a machine learning model is created under the hood for us. It's even telling me what's it doing here. So here's the analysis of the 58% increase in sales amount between December 1st and January 1st. And then we see this is a scroll bar. So we have a lot of different analytics it came up with. I think it's about 10 analytics it came up with. The first, this one with the biggest statistical influence was this one. Sales amount by date and first name, really, first name. It tells me Ranjit, Linda, and Garrett accounted for the majority of the increase among first name, offsetting the decrease of Shu. The relative contribution made by Ranjit, Jay, and Shu changed the most. So we have Ranjit and Linda and Garrett here with the increase. Then we have the decrease of Jay and Shu, and everybody else, first name is then collected in this other. And we see the starting point was 2.6 million. And then it changed up to 4.2 million. It could be even more if those did not lose anything here. But the question is this really helpful? What can we derive from those things? The danger in machine learning and AI is that it comes up with insights, but those insights are useless. And I guess this is rather useless because currently we don't see how many Ranjits and Lindas and Garretts we have. Probably, or maybe we have 10 Ranjits. Of course, they have a bigger increase than one single Linda or one single J. This would be one thing. The other thing is, what kind of learning can we have from that? Shall we hire more people with first name Ranjit? I don't think so. So the question is, why did Q&A come up, or an insights feature came up with this insight? And the thing is, because first name is in the model. So if I look it up in the fields pane, I have the employees table here, and then we see that there's the first name is available as a column here. And everything which is available and not hidden, so visible in the model, is used by Q&A, is used by insights, for example. And to get rid of this, because probably, I don't know how it is in Guatemala, but in Europe, we have this GDPR. It's really dangerous to have like the names of people or employees there and doing analytics and compare the performance of employees with each other. This could lead you into troubles in Europe, at least. So we can hide this. So then the first name disappears, and when I repeat the analytics here, so it's updating the model, then I click there again, analyze, explain the increase, we get different results. So now the first name disappeared. Now it's coming up with the gender. So M, guess it's the males, accounted for the majority of the increase among gender, and that's what we see. So from December 1st to January 1st, we had a huge increase from male employees. We had an increase from females, but this was way less. So the next question is this a good insight? Can we learn from that? I think this depends on how many male and female employees we have. And I'm playing around with AdventureWorks for many years now, and this was really an insight for me. I did not know that there was the increase was so different for males and females. Because if you take a look on so we can change the visualization here. We can do a scatter chart, which is not very useful, but we can, for example, also do a 100% stacked bar chart. So we have 100% of the sales of December and January, and comparing that, and then we see. Indeed, in December, the majority of the sales were by female sale employees, 52%. This decreased to 42% for the females in January. So we had like a movement from the majority of sales done by female salespersons, moved now to the male salesperson. So this could be interesting. So we have this possibility up there to, to give a thumbs up or thumbs down. I think this is only going back to the product team, so they can learn from that. Your Power BI file, the algorithms applied there will not change if you do the thumbs up or thumbs down, but we can do this plus symbol here. So we can add this to our page. So if we think this is a cool insight, we can change, we can add it back to the report and can share it down with our peers. And again, this is a standard visualization. I mean, we created it not a standard way. We created it by the insights feature, but this is standard visual, so we can use it like any visual. And that's what I will do next. I'm more the conservative person, so I like the traditional colors. So I will put the females in red color. And then I will add an analytic line. The only line we have here is a constant line. I put one constant line at 0.5, so 50%. So everybody can see that was the majority changed. We could also use this or create a pie chart with that, but I'm not a huge fan of pie charts. I think we live better without pie charts. And what we can see in pie charts is majorities, but we can see majorities also like here in this 100% stacked bar chart. So we can see majority was females, and now it changed to males. And then whoever in the company can then dig further and find out what was the reason. Was this just randomly, or is this something we can learn from? Any questions to the insights feature before I move to the next feature?
I think we're okay so far.
Very good. Then I will continue talking.
Okay.
So the next thing I want to show you, again, sales amount by date, and that's what I just used as an introduction for the previous demo, because I screwed up the order of my demos. Is this like, is there a positive trend or not? Are the numbers on average going up, or is it stable, or is it going down? My gut feeling tells me this is going up. Yeah? So we have an upwards trend here. And what we can do is, again, use the analytics line. For a line chart, this list is longer, as we can see here. So we have a trend line, we have the constant line, min, max, average, median, percentile, and the forecast even. Previously we used the constant line. This was the only thing available for the 100% bar chart, sorry. So trend line, we can just add a trend line. What we can change here is only the colors, the transparency, only the lookalike. We cannot change the algorithms, and we don't see the algorithm. So this is a bit annoying. I mean, we see my gut feeling telling me an upwards trend is true. So we have an upwards trend over time, and if that's what you're looking for, perfect, easy. Add this analytic line, trend line for that. But as I said, this is a simple regression line, a straight line. Maybe we want to change the algorithm, or we want to filter or base it on different other things. This is not possible with the standard feature. Lucky enough, we have more things available in Power BI than the standard feature. And one thing I want to show you is to use DAX for that. So I'm going to create a new measure in my measure table. new measure, and then move over to my file here. I'm looking for the trend line. Where is it? Simple regression line. Yeah, I don't need this one here. Move it to the other screen. And then I will copy and paste and we'll let it run, and then I will explain you what this does. So we have the measure here. This should not be the trend line. This should be this. It's a lengthy code. 47 lines, as we can see here. And then I add it here to my line chart. The new sales line. And if I create this, we doesn't work. Axis, here, not the axis, the values, of course. And then sometimes, yeah, I get this weird effect here because the Q&A feature somehow adds this filter here. Dates have reseller sales. If we remove this, then we get the trend line. So the chart now changes. So we have this trend line. The gray dashed line is the trend line created by the trend line feature, and the blue line is now the new sales amount line. If we we can now get rid of this trend line. It's not confusing. So we only have this blue line, in case you could see both lines here. As you can see, this is calculated over the whole available time frame. So from 2013 up to, what's that, 2014. So as there are dates available in the date table, it's also calculated for them. This is what we can do in the DAX statement. Let's see what this DAX statement does. So open this up. As promised you, it's a little bit lengthy. Zoom a little bit in so everybody can hopefully read this. Carlos, is this readable for everybody? Is this big enough? Just tell me. And this I took from a blog from Daniel Maslik. He's a real genius concerning Power BI and DAX, and he came up with this calculation doing the simple regression line, which is a formula which is available in many books and everywhere, so it's easy to find about the formula. But he was one of the first guys to translate this to DAX, and that's what I used here. Let's go to the back, very, very down here. So what we're seeing here, the calculation of the simple regression line. I hope you can remember this from school. I'm sure you heard about this in school. There's the intercept. So intercept is the point where the line crosses the y-axis. And then we have like the dates. For every date, there is an increase, or it could be a negative slope, then will be minus, but now we have positive. We add the slope here, positive slope. So for every day we have in the model, the sales amount increases. So that's the slope of the line, and it's a straight line. That's the formula. The question is, how do we get the intercept and the slope? As you can see from the colors, those are variables. So this is defined over variables. And if you're new to DAX, variables are your friend. They make your code a little bit more lengthy. So you use more lines of code, but it's a good thing because it's easy to read, because we can like modular build parts of the formula instead of having all those things, sum x, average x, blah, 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 in there in one line, which is really confusing to read. We have like this formula, which is really easy to read. And then we have intercept is then defined as the average of y minus the slope times average of x. The question is, what is average y, x, and slope? Slope is here. So slope, this is defined by division of this thing here, count of items, so number of items we have, times sum of x times y, minus sum of x times sum of y, divided by count of items times sum of x squared minus sum x squared. This is the formula. I think this is the Pearson formula to derive the trend line. And then again, the average x is the average x of the y, the average y is the average x of the y values, the average x is the average x over the x values, and so on and so forth. So where's the known thing coming from? The known is a filter on the available data. So we have the date on the x-axis, we have the sales amount on the y-axis, and we're ignoring everything which is empty. Basically, that's it. And this formula we can now change. So if we want to start, for example, the line not at the very beginning 2011, we can just add a filter here. So we can add the calculate statement here and apply it over the previous trend line by having this filter here. So the trend line we are showing now is starting first in 2013, January 1st. So before 2013, we don't see a trend line now. Let's see if this is working. Going back there. Then we see this line starts now in January 2013. So now we can play around with those kinds of things. And we can also, like, if it's starting in 2013, maybe we just calculate it from 2013 onwards, because that's the more current data. Why should I put a forecast on old data? Maybe I only do it on new data. So we can again introduce a filter here. So instead of having all the dates, all the selected dates, all the dates available for this measure, we introduce a filter here. Again, filter on all selected, and then the date is filtered on everything past or greater than or equal than the 1st of January 2013. If you're doing this, unfortunately, there's bad news, because within 2013, as we will see here, within 2013, we have a downwards trend. But don't shoot the messenger. That's how the numbers are, and that's what we can show here. Another way of having a trend line would be to have a forecast. So let's go here and build another sales amount by date. Convert it to a standard visualization, and then I can add a forecast here. So we can tell that we want a forecast. The forecast should be for the next 6 data points. As we have monthly data, that would be the next 6 months. We do not want to ignore any of the last points. So we start at the last point. Confidence interval should be shown. So we get this ribbon showing where the value lies within the 95% of confidence. And seasonality, we can trust auto, but usually I state that I have monthly data, so and I expect that the patterns, if there are any patterns in the data, will repeat after 12 months. So we have a yearly pattern. Let's add this here and apply it. I guess we again have this filter in here. Let's remove the filter here and then see if this is working. What's the empty clicks here? There was this other thing I already struggled last time. So everything except for the blank data. So somehow I have blank data entries with blank dates in here. So we get this forecast now. Again, this forecast, it doesn't tell me anything about what kind of forecast is here calculated. There are different algorithms available, but it's easy to use. And if this is working for me, stick with that. You even get this confidence interval. So we see this is there's a probability that the next patterns look like this. And if you look closer, you can see this is like my first name is Markus, so I will see M-shaped patterns easily. So I think this looks like an M-shaped pattern. Can everybody see this M-shaped pattern? And this M-shaped pattern starts here in November or here in December somehow. We have the same pattern starting here. So in November, we also have this M-shaped pattern. And also back here in November 2011, we have this M-shaped pattern. So these algorithms, whatever algorithm is looking for such patterns, and that's what it's using for the forecast. If you want to have more about that, again, we can, let's duplicate this, and then change this to, we have this, where is it? The ARIMA. So forecasting with ARIMA. I downloaded a custom visual. So what you can do is with this ... we have the standard visuals are always up there. Maybe zoom in here. We have the standard visualizations up there. And then I preloaded already in my Power BI Files custom visualizations. And by clicking on this ... you can get more visuals. And if you click get more visuals, it opens up a window communicating with app sources, formerly known as Marketplace. You can also import it from a file if somebody supports you with a file containing additional visualization. You can use it there, or you can also write your own visualizations. There are courses out there where you can learn how to write a custom visual. If you click on the get more visuals, then we should see. Did I click there? Yeah, it's just taking some time. If you're waiting for something, it takes extra long time. Yeah, here we go. So we have this Power BI visuals, and then you see there's a long list of visuals available. Funny things like the word cloud or the fishes, but also really useful things. That's also useful. And you can even search here. So if you're looking for ARIMA, for example, so we get all the custom visualizations containing a forecast with ARIMA. There's 2 available. This is by AQ. This one, I think, is by Microsoft Corporation. So they build custom visualizations which are not part of the product by standard, by default. And then you can say the descriptions here. So it will tell you what this visual does, what ARIMA is. ARIMA is the auto-regressive integrated moving average, and it's using R packages, Proto and Zoo. So to use this package, you have to have installed R and those packages on your computer. It's working with those R versions, and you can even take a look on the code, so you can fork this code and then make your own version of this visual. So this is as an open source visual available. That's what I loaded already here. We can then close this down, and I changed this visual to the ARIMA. I think this was this one. Yes, ARIMA. Zoom out again. ARIMA takes a bit of time to calculate, at least with this kind of visualization. And as soon as it's finished, we can see that there is some parameters we can set, but it still takes some time to run. And again, this gives a little bit more flexibility than the analytic line with the forecast, but you're limited to the features available here. So we can see there's a forecast settings available. So the forecast length, maybe change it to 6 months again. The confidence interval 99 and 95 is good. The seasonality, I do not trust the automatic thing. I change this to manual. And where's the factors? I expected that there will be, then change it to month. And then there's a model customization, and we can, for example, point in. That's what I found out works good with small p and q, d and q set to 1 to 0 1 0, and also here I can help the algorithm because I think this makes sense doing the seeing the visualization done by that, and it's refreshing here again, and then we should see a similar forecast like we have seen it in the forecast pattern. So this gives you a little bit more flexibility because we have those parameters we can set. But maybe you want even more flexibility, then we can reach out to R and to Python. Let's finish this. Does this finish in useful time? Otherwise, I will go on with next demo. Are any questions? So I screwed it up, obviously. The monthly thing did not work. Where is the this is I think it's manual, and then I get this number here, didn't I? I forgot where I could set this. Sure, I got a reasonable forecast with that visualization. No, not this one. And I'll try, I do not try anything else, maybe automatic, but I think the automatic did not work either. So you can play around with that. Here we have the frequency 12 now. I think this should work. I didn't see this previously. The 12. So with the 12, we should see the right numbers, or a reasonable line chart, because it's a forecast. We never know if this is true or not. It just gives us a feeling. No, it did not work. No, I will not play around with that more. You can play around with that because I will give you this file. So let's duplicate the thing and change this to an R visualization. So if I change the visual to an R visualization, to an R visualization, I keep the values. So values are date and sales amount. There's almost nothing to do here, only the standard things here, like the title or so on. But the secret lies in the script down there. So we get this R script editor. As soon as I click on the visual, this R script editor appears. And we get some comment lines here. So if you're not familiar with R, everything coming right off the pound symbol of the hashtag is ignored. So as this in the beginning of the line, everything here is a comment. The comment tells me the following code to create a data frame and remove duplicates rows is always executed and acts as a preamble for your script. So this is a reminder what Power BI does to give the R script access to date and sales amount, to my data within Power BI. So those two things are converted into a data frame. So we see here data.frame. There's a function in R. So date and sales amount are converted or they are transformed into a data frame, and the data frame is named dataset. And then the dataset is then all duplicates are removed from the dataset. I guess behind the scenes, this is not working like that. It's not really executing those things. It's just a reminder and showing me in R what is done there. Behind the scenes, probably this is working differently. And as we know that Power BI always only shows us unique values. If you put like the year column into a table, then you only see a list of unique years, no duplicates are shown. That's the standard behavior, and this standard behavior is also applied if you're using R or Python. Also, aggregations are automatically done. So if I move in only the sales amount, I will only get one single row in R because the sales amount is a measure, and this measure is aggregated. I only will get one row with the 80 million euros or US dollars we have seen previously in the first demo. So if you want to change this, you cannot change this behavior, and you cannot just rewrite like if you change this like here. This is only a comment. This will not change anything in your script. Just keep remembering this. This is only a reminder, and changing anything here does not change anything in the script. To get a line chart, I again reach out to a script I previously have written, so you do not watch me typing in stuff here. Paste it in here. Then let's execute this, and then we discuss the script, because I think it's easier for me to explain it if you see the actual lines there. If this is working, we should see a green line again. Green line is the actual values, so the date and the sales amount. It even tells us here, so sales amount and the order date. The text is displayed here. And then we have a blue line, which is a trend line from the previous thing we have seen. How is this done? In R, I start my script here. So I rename the dataset. I move everything from dataset to fact reseller sales because I had previously a script using a data frame fact reseller sales, and I didn't want to change the script. So I just renamed or duplicated the content of the dataset. Then I'm renaming the column names. So this is what I really think is funny. I've never seen this in another language before. Call names returns the column names of the data frame fact reseller sales. And yeah, that's returning the names, but I can assign something. So this is a left assignment. This means the thing on the right is assigned to the thing on the left. So I can override the column names by assigning something to the return values of call names, which is, I think, is a funny way of renaming column names. And C is a function to combine things to an array. So I combine two strings, order date and sales amount, those two strings to an array, and then I use this array to rename the column names. So afterwards, the fact reseller sales data frame consists not of columns date and sales amount, but it consists of order date and sales amount without the blank. That's the reason why I did this here. Then I again do an assignment, left assignment, and I filter everything out where the order date is blank, where it's empty. I don't want to have this. I could do this in the filter, of course, but I decided to do this in the R script to make sure, even if there's no filter applied in Power BI, I filter it out here to avoid errors in my script. And then I convert the order date with to the POSIX CT format, which is one of the formats you can store store a date in. You can omit this, but then you get like a really weird, it's like more text. So we get for every single date, we get a date there. If we convert this, we get this automatically shown the years, for example. So this would work without that also. And then I'm loading two libraries. So that's the power of R, having libraries available. So you can reach out to CRAN, the Comprehensive R Archive Network, And the last time I looked it up a couple of weeks ago, it was over 15,000, 15,000 packages out there on CRAN. So this is really overwhelming. If you're starting with R, you will be for sure overwhelmed by the power of packages out there. If you start with R, concentrate on handful of packages, and if you find out that these packages do not work, or you have you're coming to the limits of this package, then find another package. But it doesn't make sense to really learn all those 15,000 packages, and it's ever growing. So two packages, ggplot2. Gg stands for grammar of graphics. So this is a way of building up a plot by describing the layers this plot should consist of. So plot gives the hint it's a plotting thing, plotting packages, and 2 because it's the successor of ggplot, and ggplot is not available anymore. And scales is a package to make it possible for those nice numbers we see here. So the standard way in R is, because it's coming from a scientific or mathematic background, the numbers are usually shown in scientific notation. So 1 million would be 1E06. So 1 with 10 with 6 zeros, or 1 times 10 to the power of 6. That's what the scientific notation says. Usually I work with business users and they expect the numbers there, and this is what I achieve with the scales package. And then we call the ggplot function of the ggplot2 package, pass in the data frame, the table, so to say, factory result sales. On the aesthetics, describe what I want to have on the X and Y axis. I want the order date and sales amount on the axis. And then I describe how this should be shown. So the first geometry is a line. I want to have a line chart. And the only thing I change here from the default is I want to have it in the third color. I could also put in green as a color. Somehow I decided for using the numbers here. And on top of those lines, I want to have points. Again, for the same data, the same color. And that's why we get those dots at the spikes there. Next thing I'm doing is changing the theme to increasing the text size so it's more easily to read for you. I changed the scale of the y-axis to be sure it's continuous. By default, it would be continuous. But what I'm doing here, I changed the limits to between 0 and 5 million, so it's constant. Even if I change some small things in the chart, the axis stay the same. And labels comma is available because of the scales package. So I'm not showing the numbers in scientific notation. I omit the legend, so legend position is none. I don't want to see, I have a legend here, and I change the labels to order date and sales amount. That's how I got the green line with the sales amount. On top of that, I add a statistics line, a smooth line. And the smoothness is calculated with the method LM. LM stands for, as you can see here, linear model or linear regression model, simple linear regression model. That's the straight line. And is E to false, turns off the standard error, I think. So that's the confidence interval. If I turn this to true or just delete it, we get the confidence interval. So we get a ribbon around the blue line in a second, as soon as this is calculated again. Now we get this ribbon with a confidence interval. So this is what you can do with R. So it gives you more flexibility, but of course you have then to maintain and write a script. We can even change this to, for example, using the local regression line, which gives us a smooth line, not a straight line. And if this is more correct for your data or not, depends on what your data or what you think. If a straight line is the more thing, or if it's better to have a smooth line here, like with the local regression. That's what you can build with these things. We can build the same thing. How much time? I have 50 minutes left, so I will take some time and show you the Python integration. So we build the same thing. If I can find my script up there. Where is my script? We have the Visual Pi. Here we have it. So the trend.
Hey Marcus, we have more than 15 minutes. Go ahead,
Pardon?
don't worry. It's a workshop. Yeah, we have more time.
Yeah, more time.
here-
Okay.
Yeah, no worries. We have until 9 a.m. Right now it's 8 a.m. our time.
Oh, okay.
So feel free to take as much time you want. No worries.
Yeah, very good, very good. Of course, I will take this time. I will fill the whole of the time because I have a lot of demos and I usually cannot show everything in 60 minutes. Anyways, So very cool to know. Yeah, okay. So I take my time. I hope people are not bored by me talking so long. That's the only risk I have. So I have another script, so I duplicate this thing, and now I will show you we can build the same thing with Python. So if you're into data science, then you have to learn either language, either R or Python, or even both. And what I learned is that people either really like R and are not very good friends with Python, or the other way around. So this is really, really funny. I want to show you both here. So I changed this R visual now to a Python visual. The text down there, of course, is not executable. We get an error here because we cannot execute R thing here. So I just delete everything in here and paste in a Python script. Again, I will first execute it and show you the result, and then I discuss with you the steps in Python. So it's your choice what to use, R or Python, and you have to install R and Python on your laptop before you can execute this. So a Power BI can only make use of R and Python, but comes not with an integration of R and Python, so it's not installed with Power BI. So again, in Python, we also have packages. I don't think it's 15,000 packages, is way less. So there's not so much choice, but maybe it's easy to learn then because you're not overwhelmed by all the packages available. So we get this matplotlib package here, which gets an alias PLT. Again, for the numbers, I also load the ticker and the pandas for the data frames, and sklearn for the linear model. And then I do similar steps like previous. We have to prepare everything. So I prepare the date. Again, it's a good idea to convert the date to get it more useful, more easy to use. I think if you omit this, it will still work, but the date could be in a funny format. So what I learned is convert it that way, makes it much better readable. Then we create the model. So I create a variable m and call the linear model linear regression. Call the linear regression. Call the linear regression function of the linear model package. sklearn has the alias linear model here. And then I train the model. So I give the model data where it can learn from how to shape the trend line. So I pass in the date and I pass in the sales amount. I have a black in here, so I have to put this in this square brackets. And for the Python logic asked me to reshape the thing with those parameters. So that's why I'm adding it here. Then I create the prediction. So I create another entity, m.pred, using the m.prediction function. So m is my model, and I'm calling the method predict from my model m. Like I use the fit method, I'm using the predict method now, passing again the date, and then adding these predictions as a new column prediction to my dataset. So my dataset now consists of date, sales amount, and a column called prediction containing the values for the trend line in here. And that's what I'm plotting then. So create the plot as the last step. Every time you have a R visual or Python visual, you have to have a plot in it, otherwise it's not able to show anything, of course. And I use the plot function from the matplotlib. So here it is from the matplotlib, and applied on the dataset. So the dataset is the data containing the date, the sales amount, and not the prediction. On the x-axis, I put the date. On the y-axis, I put the sales amount. Color, I chose to have the names here. Color is green. The style should be a line, so not a scatter thing or something else. And the fixed size, I played around to fill out this format, the space available in Power BI, as good as possible. So with that we get the green line, and as the next step, I put on again the date and the prediction without the color, and the default color is blue. That's why we get this blue straight line here. Then I changed the label, date and sales amount, and I changed the tickers and the scales here. So that's what I'm doing here with the y-axis. Finally, we have to use this PLT show. That's the most common thing I forget writing Python script for Power BI, and then you earn an error message that something is wrong. PLT show is very necessary. So that's the Python version of this thing. And we can also, of course, do predictions. Now we rebuild the trend line, but we also have seen that we can have the forecast in Power BI, and of course we can also have forecast in R. We can have forecast in Python. So I duplicate again to make it easier for me. Have the R script in here, and I'm looking here for where's the R script? Somehow the order of the files is changed. Here we go. And I want to, was it Arima? Yeah, here we get Arima. Yes. Is this the right one? Should be. Let's run it to see if it's working. So we are jumping back and forth with R now. No, it's not working. What's wrong here? No image was created. Yes, because this is not the right. Here. I just omitted and forgot to copy the rest of the script, having the plot in here. So let's see if this is working. Should be Arima again, so the moving average thing here. So again, in green is the actual data, and blue is now the forecast calculated with Arima. So somehow it thinks that it will be way higher than it actually was. So what I did here, I plotted the Arima on the forecast on the last three actual values. So we see there's it expected more an upward trend than we really had. So this prediction is not very good. But for the sake of showing you what we can do in R, it's good enough, I would say. Again, I'm using lots of packages in here. As this is open source, there's no standard how you name your packages. So there's really funny names of packages. So there's Sue. There's also lupridate for to transform dates, for example. There's really funny names in there. So this is really geek-like, which is funny, but on the other hand, it doesn't tell you anything what this package does before you look up. So don't depend on the name. It could be anything because the name is not standardized. Again, prepare my dataset here in R. So I'm converting the date with POSIX-CT, and then I find out about the time series in here. So there's this time series function, which is from the Sue or from the forecast. I think it's from the forecast package, where I get analytics about the time series, which I'll then use as a parameter for the Arima. So I tell Arima what kind of time series I have, and then use the similar parameters we've seen before with the small letters and the capital letters, all 1O. This is something you have to play around and find out what to tune your model to get a reasonable outcome here as the forecast. Then I predict with the help of this model. So I use the predict function, passing in the model, and I ask for the next 6, in my case, months. And then I build a data frame. So I merge everything into one single data frame. So I have the date. Had to convert this a little bit. And I pass in the sales amount as a placeholder with NA currently, and then the prediction. So there's a new column, sales amount pred, with the predicted value. And then I merge everything into one single data frame. So I have the data set, which are named date and sales amount. And from the second data set, I get the date and the sales amount prediction. And I merge it by date. So it's like a full auto join by date. So good. The same date and then the sales amount and the sales amount prediction in one single data frame to make it easier to plot them. And again, I'm using the ggplot package here. So the date and the sales amount on the axis. This is one way of having a column with a blank. You can use the get function. So that's why I usually stay away from blanks in here, because it makes my code more lengthy. I have to call a function to get the column when the column name has a blank or a special character in it. Again, in color 3, so it's the screen. There's a little change here because the prediction is so high. I had to increase the y-axis, otherwise it would be cut off at 5 million. So increase it to 6 million. And then I do the geom line. So I'm not using the start smooth, but draw another line. So we can have geom line multiple times. And for this time, I don't plot the sales amount on the y-axis, but I plot the sales amount prediction on the y-axis. And again, putting points there, so we can see that there's a change in there's a actual data point there. The rest is the same. Theme, legend position is turned off, and then I draw date and sales amount on the axis. So this is how you can do a prediction, for example, in ARIMA in R. We can do the same with Python. So I'm duplicating the Python thing and looking again for my Python script there. Where is it? Here we go for the Python script. And is it the next one? Here is the ARIMA. And I make sure I pass in everything, so we don't get an error message. Passing there, and let this run. I think the ARIMA algorithm is a little bit different, so the outcome is a little bit different here. But again, it's the ARIMA expects a very high value there, so the M-shaped pattern is up there again, almost close to the 6 million. And I'm doing basically the same here. So if you learn to build one of the charts, probably it's easy to learn also to build other charts, because it's always the same thing. You import your packages you want to use for that. In this case, I'm using the stats models API to use the ARIMA algorithms from there. I have to change my date format. I had also to add an index to my data frame, so the stats model can work with that. And I'm summing up the sales amount, so I get one value per month start. So in case there's the dates are spread around the months, I move everything to the first of the month and add the sales amount up there. Then I create the model, which is a special case of the ARIMA. I can't remember what the S and the X stands for. I forgot it. But this is also based on ARIMA, passing in the Y values. This is the sales amount, and my parameters in the seasonal order is 12, because I expect this is a monthly data. Then I create the forecast for the next 6 steps for the next 6 months. I want to get the forecast, put it into data frame m.fit, and then I finally plot the m.fit. So I start a plot with label sales amount green, and then I plot the predicted values with label prediction. And I also have here the y.plot means that I plot the y data frame, which consists of the sales amount and the date. So this is what we get in green, and the rest we get then in blue as the second color. Then I set the labels again, set the x-axis, put on the legend in this case. So we have the legend in here. If I omit this, then the legend is not shown, and I show the plot. So this is what we can do with R and Python, for example, in here. Are there any questions so far?
Oh, there was a question here. Just let me turn on my camera. So do you need to have a Power BI Pro subscription for all this stuff, or is just out of the box with the normal license?
Do you have a Power BI what?
Subscription?
A subscription? No. Everything I'm showing here, oh, very, very good question, because this is important, I guess. Everything I'm showing here in my demos is free of charge. So you can use the Power BI desktop without any license. I mean, I'm logged in, so I have a pro license assigned here, but I'm not using it. So everything I'm showing here, you can do with free versions of software. So Power BI desktop, which is for free, you don't need a pro license, you don't need a premium capacity. R is open source and for free. You can install the OpenR, or you can install the Microsoft OpenR or the OpenR. You can install the Python, which is for free. So everything I'm showing here is for free indeed. Yeah, believe it or not. Yeah.
Nice. That's nice.
Yeah. I know. Yeah. If you upload this to the cloud, so if you publish this report to app.powerbi.com, then please make sure that you use this. The R and Python scripts will work there, but of course you cannot maintain it on your own. So somebody at Microsoft decided what kind of packages are available and what versions of those packages available. So please make sure, I think I can put a link in the Slack channel afterwards where you can find which packages are available. I think only roughly 500, 600 packages in the case of R are available in the service, and certain versions are available. So make sure, if you want to play around with that and use this in production, to install only use those packages that are available in the service and install them on your PC with the same version. To otherwise there will be some surprises, because then the maybe your chart looks differently than in the service because it's a different version.
Oh,
cool.
Nice.
What I did not show you is also that you can, because editing stuff in here, so I copied and pasted always the stuff in here. So usually I do not write my scripts in here. You get some syntax highlighting, as you can see here. There's some support, but it's yeah, I do not prefer writing my scripts in here. The thing is, my data is in here in Power BI. So the bad thing is, if I write the script in, for example, the R editor, how do I get access to the data? Because I have Power BI here. I probably use Power Query to shape the data, then I put everything into a model, and then I put the things in here. But how can I access this from our editor? And the good news is there are nice buttons in here. And one button is the settings in here. So script options, if you click here, or if you click on File, Options and Settings and Options, that's the same thing. So if you click there or select it from the ribbon, you get to the options of Power BI. And here you can change the R scripting and Python scripting thing. I zoom in here a little bit. So one thing is that you have to point Power BI where R is installed, and you can have multiple R versions installed. As you can see here, I have R Open installed in 2 versions. I have the ML server of Microsoft SQL Server running. I have also the open version of R running here. So just point it to the right thing where you have installed all the packages. And you can also point it to RStudio. Something, my screen is flashing. I hope this is not a bad sign. RStudio. So the IDE, the integrated development environment, and we can use the integrated development environment by clicking on this arrow, edit script in external editor, it tells me. If you do this, our editor is open because that's what I turned on to the options. I pointed it to our editor. So our editor is running here. And it's not only copying the script over there, but what is really cool, everything, all the data I have available in Power BI in my script. So we have a data set available. It's told us, but we have the date and the sales amount available. This is injected to the script as a dataset named dataset. So all the data is automatically exported to a CSV file. So in a temporary folder, R editor blah blah blah, with some names and folders, and then some a CSV file. And these lines are automatically added to my R script before this is opened in RStudio. So now, if I execute this, I have the dataset available in R. So if we see there's now a dataset available, and this is exactly the data I have in Power BI. 32 observations, so 32 lines and 2 variables. And we can see the data set, for example, and then we see, yeah, that's the data we just have seen in Power BI. And now I can work in R editor exactly with the data, shaping my script, and then copying everything except for the first 3 lines back to Power BI, and have my script running. So if you execute everything here, it should also show the very same chart with the prediction, the ARIMA prediction. I think this is what that shows here. So we get the chart here. We can even zoom it here in our editor. You can, of course, you can install other editors, but I think for R, the R editor is very common. So we see the same thing here, and now we can play around in our editor, shape everything until it's finished, if we really like it, and then copy it back to Power BI. And the same is true for Python scripts. So there's also these options for Python available, and I'm using the Visual Code for that with a Python extension. So if I'm opening up that, it will open up Visual Studio again, exporting all the data. What is it? Okay. Now I see that you see something what I don't see. Here we go. Here we go. There's this weird find thing. Okay, this is only here. So we see now again there's some lines added to make it available, make the data available. So again, it's loaded as a data set. Everything is exported to a CSV file first. Everything is exported, and there's some settings automatically added. And from here on, then my original script is added. And at the very end, there's an epilogue. So you would then rewrite your script, shape it as you want it, and then copy everything back except for the first lines and for this epilogue line back to Power BI. And sometimes I have the feeling that like data scientists, they work with open source thing that usually not really in love with tools from Microsoft. But if I showing them that how easy it is to shape your data in Power BI, and then you have the ability to just export this as a CSV file, working around in your R editor or in your Python editor of your choice, this is a killer feature, I guess. People start then also like working in Power BI, because like publishing everything in Power BI is then rather easy. You build up your R script or Python script visuals, exporting them or publishing them on the service, and you're good to go. So let's go back to Power BI. I will show you two other use cases, I would say. If you're still sticking around, yeah, then I will show you another thing here. This is the date. Let's do some correlation analysis. So I have the date here, and then I add, what do we have here? The discount, the freight, the order quantity. There's two order quantities: the product standard cost, the sales amount, the tax amount, the total product cost, the unit price, and so on. And if you look on those lines, so one thing, I added the date here. If I do not add the date, just to make sure everybody understands this, then I only get one single line because everything is aggregated. That's the thing. That's the standard behavior by Power BI. So I add the date to get different lines, where I can then try to find a correlation. So correlation would be like if the discount amount increases, so 0 to 1,600, does the freight also increase? It did here, but here it decreased again, and the freight increased. Is there a correlation or is not? So correlation is like a statistical correlation. One thing changes, does the other thing also change? Does it change directly, or does it change indirectly? So one thing increases, the other thing decreases. And looking at numbers can be fun, but finding out about correlation, I think, is really, really hard. So what we can do here is, again, we can reach out to smart visualization. So there's a correlation plot available. If I change this to this correlation plot, so my map, my table is then changed to a correlation plot, we get a good picture, I guess, because now we see this blue and red dots. So what we see here is, shall I zoom in? Maybe it's better if I zoom in so you can read this. So we have like all the columns I've chosen, discount amount down to the unit price average on the lines and also on the columns. So we get like combinations of all of everything. We see these blue dot lines, really dark, not lines, those blue dots, really dark blue dots. Here in the diagonal, because of course, if the discount amount increases, the discount amount increases, because those couples always have a one variable, of course, has a very strong correlation with itself, and a big blue dot means that we have a strong correlation of 1. Is there any questions, Markus? I only hear distorted noises.
Yeah. Marcus, do you want to?
Yeah.
It's
Yeah, Carlos?
on the screen. Yeah, can you hear us okay?
Yeah, I can hear okay. Yeah, yeah.
Okay, great. So we have a question from Alberto Reina. He says, is there out there a book or course about this? The R part seems to be very interesting working with Power BI.
Yes, there's let me I think there are books out there. Also the R community is rather active, so I'm pretty sure. I've never been to Guatemala, but I think there is an R community somewhere in your corner of the world. The R community is rather active, so if you want to meet people working with R, watch out for the R community there on Meetup, for example. There is even this, like, maybe you noticed that the SQL Saturdays, there's also a set R day. So they're playing around with words. Set R day for a Saturday dedicated to a conference playing around with R. So this is one thing. The other thing, there are plenty of books out there. Maybe if you shoot me an email or shoot me, ask me directly in Slack that I don't, not in Slack, yeah, Slack, so I don't remember, then I can find some books for you to start with R or whatever level you're currently in R. So there's a lot of books. There's also video courses out there. And yeah, so yes, there's a lot of stuff out there. And it can be, like the packages, it can be overwhelming because there's a huge community with a lot of activities. So I'm sure you will find that there are things there. And of course, I can help you finding stuff. Also, what's the official name of the R homepage? I just can't remember right now. So this is also a good starting point because there's blogs out there. There's regular links on video courses and so on. So yes, the answer is yes. And I'm sure if we discuss something in Slack, we can find something, a book, a video course, or a blog where you can start from. So back to the correlation plot here. So we see the correlation plot, and those blue dots are because... Another question?
Yeah, we have more questions. Would you like to address those questions at the end, or do you want to move on? It's up to you.
No, come on with the questions. I think this is good to already talked over 60 minutes, so people have to be entertained, and maybe it's better to answer questions instead of keeping me showing more things.
Yeah, that sounds great. It's okay for us to post your email on the chat window.
Of course, yeah. Gmail, email, put it there, or the server data.
There. And this question is from Alejandro Donis. He says, is this based on some Azure cognitive services or powered by Azure Machine Learning?
Again, a very good question. So what I'm showing here is not based on any Azure services. Everything is running on your computer. So you have to install R or Python to run those R scripts or Python scripts I just did show you. And of course, we can reach out to cognitive services and Azure ML, which maybe we skip the correlation plot and I just go directly to that as the next demo, where we can reach out to cognitive services and Azure ML. So this is the Azure services for everybody who's not familiar with those services. So there's two ways machine learning things are available by Microsoft Cloud. One is cognitive services. Cognitive services are pre-trained models. So somebody at Microsoft trained those models. So they have a huge team of data scientists and tweak the models. So you don't have to take care of training the models and coming up with your own model. There is, for example, a visual API where you send over a picture and it sends you back a list of texts of items which can be seen on these pictures. Or we can send over a text and it comes back with the key phrases. So we can build up a word cloud, for example. That's something I can show you in a demo in a minute. So this is not very flexible, but it's easy to use because you just use the cognitive services. Azure Machine Learning Services put a little bit more flexibility into it. So you then train your model. So you're more flexible, but you have to put in your brain to train the models. And then you can turn convert those models into a web service, and the web service can then be consumed like cognitive services, for example, by Power BI or by any app you're writing, or your web page. For example, if some customers registers with your web page, you can find out where he lives and what he could be interested in, depending on what you already know about your existing customers. Or you could upload a picture, and then the web service tells you, is this a dangerous form of cancer, or is no cancer at all visible on there? Alejandro, did I answer your questions? Hopefully.
Yeah, I think we're okay. We can just move forward. And we have 30 minutes left, so we're okay on time as well.
Yeah, very good, very good. So maybe I pause here the correlation plot, and I show you how you can use the Azure Machine Learning Service and the cognitive services. And before I do that, I show you the word cloud here. So we can build a word cloud. For example, I have this in the product table. I'm not sure if you're familiar with the English description. Yeah, here we go. With AdventureWorks, but in the product table, there are text columns describing the product. So there's an English description, and I always was wondering, before I came up with this Power BI talk, I was always wondering, what can I do in SQL, for example, with the English description? Of course, we can read through the text, a light, yet stiff, blah, 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 a true multi-support, blah, blah, blah. But what can we do with this kind of data? What we can do is, for example, we can put this in a word cloud. So word cloud is not a standard visualization, but we can really do it. Should be the don't have the word cloud. Here is the word cloud. I can convert this to a word cloud, and a word cloud will then look up all the words there, count them, and depending on how often a word is mentioned in the text, the more prominent it will be shown in the word cloud. So for example, we see, unfortunately, the, a, for, and, with are very common words in the English language. So that's why they are put very common in the word cloud. But I would like to ignore those, because this does not give me any hint about what the texts are. Every English word will consist of many a, the, for, and, with words. But what I'm interested in is more about aluminum or riding or bike or something like that. So one way to make this available is to reach out to cognitive services and Azure Machine Learning Services. So I duplicate this word cloud, and I then don't use the English description, but I already use this here. Like, let's begin with the cognitive services. Cognitive services, I have the key phrase in here. So instead of the description, I put in the key phrase. And what we should see is that all the N, the for, and so on disappeared. And now we see, mountain, road, aluminium, frame, bike, touring, seat. That's obviously important words in my product descriptions. We can do the same. Again, I just show you first the way the result, and then I will show you how we can reach out to. This did not work, so we can reach out to the services. So key phrase, I put the Azure Machine Learning here, make it maybe a little bit smaller, and I put it again over there. So I built the same thing also with Azure Machine Learning. So we have the product Azure Machine Learning, the key phrases, and I put the very same thing, I created the very same thing also with Azure Machine Learning Services, but did run my own R script. So this is also possible. So R, and here we go, key phrases, again, key phrases. And they look very similar, especially those two look very similar, because under the hood in Azure Machine Learning Services, I did use the pre-trained version of key phrase detection. And probably, most likely, those are built on the same model. So the cognitive services, maybe I changed the title in here. So we see here the cognitive services title. This is built by cognitive services. And this one is built by lacking here. Azure ML. And this is also built by Azure ML, but I used R. Go on. Yeah, never type in the demo because there will be always typos, HTML. So how did I get the data in here? So we see the data, we can use it, but how did I get the data? If we change to Power Query, so if you're new to Power BI, then there's two tools with Power BI. We have Power BI, where you have the model and all the fields and build up a report. And we have Power Query to extract and transform and clean up the data, sorry. So this is two different tools. So we have the Power BI window here in the background, where we see the word cloud, and I now started the Power Query editor, which is a different tool within Power BI desktop. And for the cognitive services, I, as you can see here, I came up with four functions. So I have a function for the key phrases API, for the languages, sentiment, and translate API. Those are four things I've just chosen there. There's plenty of cognitive services, as I told you. There's also for the vision. I think there's also one for audio, where you get like sent over audio and then get back a transcription of the audio. There's lots of things changing there. Never-ending growth. And I then have the endpoint and the API key defined here as a parameter. So I use them in my functions. So this is the authentication to the cognitive services done over an endpoint and over the API. So the file I will share with you will consist of an API key, but this API key is dead. So you cannot use my cognitive services I am paying for to play around. So you have to set up your own cognitive services, which is easy to do. And if there's time, I will show you shortly how you can do this. So what I did here is the product for the table product cognitive services. I just copied my product table and then applied those functions. So again, starting backwards, first show you the result. And if you have seen the result, I show you the steps. Now the preview is also is refreshing now. I hope this will not take ages. And on this table, so the source is only the product table. I then invoke those custom functions, expanded those tables, and then we should see, here we see the product key, we see the English product name and description. Those are those two columns out of the product table in AdventureWorks. And then I extracted the key phrases. So of course, for adjustable arrays, the key phrase is only adjustable arrays. The first rows are really, really boring. Let's go a little bit further downwards so we get real text in the descriptions. So I think the first columns, the first rows there don't have any description. They only have the product name. So that's why it's a little bit boring here. Let's see if we can scroll down there. In the other columns, we see I also ask for the sentiment. So the sentiment tells me if this is a positive formulated text. So well done or really good thing, that would be a sentiment of 1. If the sentiment is bad, we would be close to 0. So if something writes that this and this company did a bad job, then the sentiment will be close to 0. I also extracted the language as a name and the ISO, and I also translated the things over there. So let's go down there. Can we see the translations? I translated, of course, I'm an Austrian, so the language in Austria is German. So I translated things to German, which sometimes works. So Speichen does make sense. Siedlag, this is the English thing. I think there's no Stamm in bikes. So sometimes this works better, sometimes it's not so good. Or like here, Sport 100 Helm, Blau, universell, fit, gut belüftet. This makes sense. It's a good translation, I would say. And back over there to our key phrases, then we will see here the key phrases are extracted. So Sport 100 is just ignored. The first thing extracted is blue, universal fit, and so on. So that's the key phrases. Done by cognitive services, which I use then in one of the workloads. So what about the functions? So to call the things, I invoked custom functions. As you can see in the applied steps, how can you invoke custom functions? You just click on a column and then tell the tool to add a column, invoke custom function, and then this function is already pre-chosen in the dialog. So you give it a name and function query, for example, the key phrases API, and I pass in the English product name. And the key phrases API is available here because this is a function defined in Power Query. So this is how you call the function. But how do we call cognitive services? This is done in the function itself. So if you click on the function, you only see the parameter. So this only has one parameter, the text we want to extract the key phrases from. If you click right click and then tell it to see the advanced editor, and you know the joke in the beginning was it's called advanced editor because the user has to be advanced to be able to work with this editor. So the editor was not very advanced in the beginning. It's a little bit better now. So we have syntax highlighting, or we have this colors in here. But still, if you compare it to Visual Studio or anything else, this editor is not an EDI. This script I took from the documentation. So there's an official documentation from Microsoft about the cognitive services and how we can invoke this in Power BI. So you will see some samples for the text analytics and other things. I changed it a little bit. So what I did here, the original one suggests to put the API key here. So when I do the demo, everybody can read my API key. This would not be good for the first. And for the second is, I have several functions. So I have the key phrases API. I also have the languages and sentiment API. And every time I change the API key, I would have to change my script. That's why I put everything into the parameter down there. So that's the reason why I have this parameter here. The same is true for the endpoint. I mean, the endpoint, as I live in Europe, I've chosen North Europe because it's the closest Asia endpoint for my region. I also used it here and then only changed the so-called folders to reach out to the key phrases, for example. So this is what I changed. And at the very end, I think I changed something here. Did I? No. I think the rest of the script is just as it is. What does the script? It takes this text as a parameter. So you've seen this here, enter text, tells text because this is named text, and passes it into this M script. So this is Power Query language, mashup language, or short M. This is not DAX, this is a different thing. And then I just copied the script, changed it a little bit. As I told you, I will share the Power BI file so you can use this flexible script, just copy it into your file. And what the script does is it converts the text into a JSON, because that is what the cognitive service expects. It doesn't expect only a text, but it needs a JSON document. And this document is then added with what text it is, English, and then the text as a JSON formatted thing. It's converted to a binary. Then there's a header applied, OCPM, APM, subscription key, blah, 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 where the API key is then passed into. And then this is sent over with the web contents function using the endpoint. The headers, we just built there. Where's the headers? Here's the headers. We built the headers here. And the content, which is the bytes body. The bytes body is the binary JSON file. This is passed over to cognitive services. Cognitive services then returns a byte representation of the thing, which is again a JSON document. And then this script converts the JSON document back to a text, which you then give it the return value, which is then a comma-separated list of the key phrases in this case. And that's it. So you can reach out with that. Again, if you don't have any license, no pro license, no premium capacity, that's the way you use it. But cognitive services is not for free. There's free subscriptions available to try this out. But sooner or later, probably if you use this really in production, then you will hit the limitations there. So there we are. This is not for free then. Cognitive services can be invoked even more easily. There is this, is it at column? Yeah, we have this AI insights here. So we can reach out to text analytics, to the key phrases, for example, or like passing over an image, and then we get back what's on the image, or even Azure Machine Learning Services with these AI insights functions. But those are only available for the first two if you have a premium capacity. So then you can use this functionality, and the premium capacity will then like hide the complexity of having this function I just demonstrated for you, and it is executed on your premium capacity. That's why you don't have to pay extra for the cognitive services, but you then have to pay for Power BI. Similar true is for Azure Machine Learning. If you're using this, then you have to have an not the free subscription, which is available in the Studio Azure ML, but you have to pay to have an basic or enterprise subscription to make use of that. So then you have to pay at least for Power BI or again for the Azure Machine Learning things. What I did here, I used the free version of Azure Machine Learning, which you can see here. Again, we have two parameters, the API key and the request URI. And what I did here, not really me, but a good friend of me, Gerhard Brückel, made up a script here, so we can take a look here, converting stuff into JSON with the help of only the AMP script. So this was done by Gerhard Brückel back in 2016. You have the link to the blog there. Check out not only this blog, also the other blogs. Smart guy, of course, because he's Austrian. And this script is converting, again, the text into a JSON depending on the data pipe detected for the text here. So there's one to convert the Azure ML, also to a JSON which can be read by Azure ML. The other function is converting the other way around. So the result set can then be converted from the JSON I get into a text, again from Gerhard Brückel, and the function making use or calling the Azure Machine Learning Services is down here, Advanced Editor. So this is similar to the other one. We are converting everything into making up a table, having the URI and the web service API key in here, the table to score in here, and then the web contents function again. Everything is sent over to, in this case, Azure Machine Learning Services, and the output is then converted back to a text file. So that's with the bird's eye view. If are there any questions, or shall I show the Azure Machine Learning Services and cognitive services how you can set this up? Carlos?
Yeah, so I'm afraid we have 5 minutes left at this point.
Okay.
I don't know if you have anything else you would like to show before we wrap up.
Then I will wrap up, I would say. Cognitive services is easy to reach out, so just show you that on the portal of Azure Machine Learning Services. If you go there to the portal, portal azure.com. There you can then sign in, have your subscription assigned, and then you just create a cognitive services there. That's it. From there, you get the two parameters, so the API key and the UI. The same is true for Azure Machine Learning Services. And in the slide deck, there's screenshots how to find the API key here. So maybe we wrap it up now. So I already talked for a long time. Hope it was not boring for you. I hope everybody learned something. So this is the wrap up. I did show you the question and answer feature. We can type in your columns and measures, and you will get an answer back from that. So there's also the link if you want to learn more about the feature. I only showed portions of this feature. Then I did show you the insights feature, where we ask, please show me the difference. Explain me the increase, why we had so much more sales in January than we had in December. And then we found out first name was not a good insight, but the male, female, the gender distribution could be a nice insight. Something was different there, at least statistically. The analytic line, we use 2 times, one for the constant line in the gender distribution to show the 50% line in the 100% bar charts, and we also used it then for the trend line and for the forecasting. I did not show you the key influencer visual, which is really cool. Check it out here, and also the decomposition tree, which was available back in what was the performance point services. If you're long enough around, you can remember maybe the performance point services. There was the decomposition tree available that disappeared, and now it appeared again in Power BI. Cool feature. Check it out on the link. Smart custom visuals, I did show you for the ARIMA. We did with that. I started the demo for the correlation plot, but did not finish it. This was also custom visuals. And some of the custom visuals are built on R, for example. So you have to install R on your computer. And if you are installing that, you can also run the scripts in that, before we come to that. We have the what if parameter, which I did not show you, which is kind of artificial intelligence, but you have to come up with your own artificial intelligence. So the what if parameter basically creates a table with a lot of values in it. So you can define what kind of values you want in there, and then you have a slicer and choose something. And that's how the user can interactively change the behavior of your script. For example, think about the ARIMA, where we can have these parameters with 0, 1, 0, which we entered. Maybe it would be better with 1, 1, 0, something different like that. You could put with the what if parameter a slicer on the screen where the user can change those parameters, which then influence the behavior of your script or influence the behavior of your DAX script. Think of the trend line, that we just change something in the trend line in the DAX measure by referencing those what if parameters. Our integration, we have seen one thing, the visual. I did not show you that you can also have an R integration as a source and as a transformation Power Query. Check out those links if you want to learn more about that. And the same is true for the Python integration. We've seen the visual, and this is also available as a transformation source in Power BI, Power Query. Cognitive services, that's what I did show you at the very end. And here is the hints where you find the key and the endpoint, which we then use as a parameter in my file, so you can start playing around with that. The same is true for the Azure Machine Learning Services, where you can either use pre-trained models, or you can self-train your model. You can even run an hour Python script within Azure Machine Learning Services, and then with a few mouse clicks, you turn this around or create a web service for that, which you then can use in Power BI. Again, here are the hints how to find the API key and the web service URL. I did not show you because there was no time for the column by example, which is really cool. So if you create a new column in Power Query, of course you can write a formula, but the other way, or the smart way, is to just type in examples. So you mark some of the columns and then type in what you want to have in the first line. And usually we discover with one or just a few examples, Power Query will discover what you are up to and will create a formula for you. And the same is true for web by example. So web scraping, if you want to have a web page as a data source, you can also supply examples, and Power Query will then find those elements on the screen, on the web page, which you are looking for, and then load the whole table for that. docs.microsoft.com is your friend. There's a lot of documentation out there, and if there are further questions, I'm already answered some of them. Is there more time, or we walk over to Slack and I will answer them there?
Thank you so much, Marcus. That was a very interesting presentation. Thank you so much for your time and being here with us today. Marcus, your Microsoft is finally working, right?
Yeah, at last.
Right, for the next session, for the keynote.
Yeah.
Yeah. Is there any questions from the audience at this point? We don't have much questions. I think people is really interested and they are engaged with what you just presented today. I think the main question was where they can learn about this stuff, and you share some thoughts about it. But if you have any other recommendation how they can get started with this technology, I mean for everything, Power BI or anything else, that would be great if you can give them some great points or advices there.
Yeah, let's do that over in Slack, I would say. Yeah.
All right. So for those that are watching this presentation, please join us at Slack, so Marcus can follow up any questions from you. Excuse me. The next session is why Kubernetes. Well, actually, yeah, I think the next session is at 9:15 today. Why Kubernetes from Nigel Polton. He's a professional tech trainer and also Docker captain. So please don't miss this. The session will be great. I think we will have a welcome presentation coming up at 6 minutes from now, right, Marcus?
9 a.m. Yeah, 9 a.m.
Yeah, so 6 minutes from now. I think that's all for this session. Please join us, and once again, thank you very much, Marcus, for your great presentation today.
Yeah,
Thank you for having me. Gracias.
Oh, thanks to you. So that's a wrap. And please follow us to the next session. As I said, 9:15, Niger-Polton, and 9 a.m. They welcome from all the communities from Guatemala. So thank you so much for everybody that is here and everybody that is watching the recorded version of this video. So thank you.
Thank you.
Markus.
Bye bye. Be safe.
Bye-bye.
Bye.
Bye.